students, today's agenda is to check homework. We'll be learning about transformations with squares, and today you will be able to do 8.5. Today students will be able to graph transformations with square functions. And if you recall from lesson 8.4, these will be the lines or curves that you will get by graphing the mother graph of each one of these ones. In 8.4, we went over some examples for the square root. And so this is the cheat sheet that we used in 8.4, but if you don't have it, you can go ahead and pause the video and copy it. For translations, it means it moves up, down, left, right, but the graph stays the same. It looks exactly the same with translations. When you're adding inside of or outside of a parenthesis or the square root or the absolute value, it will move on X, meaning left or right, and it's opposite of the sign. If it's plus H, it shifts to the left, not to the right. It shifts towards the negatives. Ahead in the input. When you're behind in the input, in the months, so it shifts right. So if you're adding or subtracting inside, it moves on X to the opposite of the sign. If you have addition or subtraction outside of the parentheses or outside of the square root or outside of the absolute value, it's going to shift on Y and it follows the sign. So if it's positive, it shifts up. If it's negative, it will shift down. Okay, just like in the last lesson, we're not going to be creating tables for all the graphs. However, I do want you to see where y equals x squared comes from in the graph, or where the graph comes from, where the parabola. Okay, so I'm creating here a table, and we're going to have x and y. And what you want to do is to put values in the middle. You know what? I'm going to create two more. And I'm going to put 0 here in the middle, and then we're going to put 1, 2, 3 up, and then -1, -2, -3. When we want to find the value of y, what we're doing is substituting the value of x so that we can square it. And so y is equals to the value of x, meaning this 3 right here, and raised to the second power. And 3 to the second power, or 3 squared, is 9. So that will be the first value for y. For the next one, is going to be y equals 2 squared. It means 2 times 2, which is 4. For the next one, y is equals to 1 squared. 1 times 1 is 1. And then in here, we have y is equals to 0 squared. 0 to any power is always 0. Or 0 times 0 is 0. For the next one, y is equals to -1 squared. Be careful in here, the -1, the entire, including the sign, is going to be squared. What -1 squared means, it means multiplying -1 times -1. And so negative times negative becomes positive, and 1 times 1 is 1. Even if we have -1 as the value of x, we still have a positive once we multiply the signs. Same for the next one. -2 is the value of x, but we square including the sign. -2 times -2 is +4. And y is equals to -3 squared. -3 times -3, +9. So you can start graphing from whichever point you want. If you feel more comfortable, you can do 0, 0. That's the vertex. And then you can do 1 and 1, or you can start 3, 9, 3, 9, 3, 6, 9 is right there. 2, 4, 2, 4 is right there. That's 2 on x and 4 on y. 1, 1, it's 1 on x, 1 on y. Remember that this is the values to go to the sides, and this up and down. Then in here, -1 on x, but +1 on y. So it wouldn't be negative and negative. It's negative on x and positive on y. -2, +4, -2, +4. And finally, -3 and +9 right there. And so now you can see why when we have y equals x squared or f of x equals x squared, we have a parabola. Because when we are multiplying two negatives, they also become positive. So positive, so it goes up, and then positive on the negative of x. This, when it's only y equals x squared, that's going to be our mother graph. And in the examples that will come, I already created those graphs so that we can just show the difference of the transformation. What happens when you're subtracting 2 and adding 3? Well, let's go to our page in here. Well, we said that if we're subtracting inside of a parenthesis, it's going to shift to the right. And so, to the right 2 spaces, and if you're adding outside, it's going to shift up. So you have 2 transformations in here. You're moving it to the right 2 spaces and then up 3 spaces. And we will do that with every single point. So from this point, we're going to move 1, 2, and then 1, 2, 3. This is going to be my vertex. Then we have these other 2 points at -1, 1 and +1, 1. So we move this 1, 2, 1, 2, 3. And then this one is 1, 2, 1, 2, 3, marking with more pink. So these are the other 2 points, and then at 9. Okay, I'm just going to count for each point the 2 to the right. Remember that on x it's the opposite, and 3 up. So from this point, 2 to the right and 3 up is right there. From this point, 2 to the right and 3 up is right there. And the last point, 1, 2, 1, 2, 3. And this one is 1, 2, 1, 2, 3, somewhere about there. And now we can create our new graph, our transformed graph. And there you have it. So this is my mother graph, and this will be the new graph. Now in here we have something being subtracted inside. Again, it's going to move to the right 1 space. If it was plus, it would move to the left, okay? And outside, you're subtracting, so it's going to shift down. So 1 to the right and 4 down. I start with the vertex, and you can start with any. Let's start with this one. So 1 to the right and 4 down is right there. 1 to the right and 4 down is right there. 1 to the right, 1, 2, 3, 4 is right there. And then this one, 1 to the right, 1, 2, 3, 4 is right there. Then this, on the other side, we have 1 to the right, 1, 2, 3, 4. 1 to the right, 1, 2, 3, 4. 1 to the right, 1, 2, 3, 4, right there. And now we have our new graph right there. So this is our mother graph, and this is our new graph. Okay, with this one, we have something more going on inside of the parentheses. So to move it inside, first we have to divide by the constant by the coefficient of x. Remember, constant is whatever is being added or subtracted, and we're going to divide that by the coefficient, meaning the number that is being multiplied by x. So in here is -9 divided by 3 will be -3. When we have inside -3, it's going to shift to the right. So it's going to shift to the right, but 3 spaces. The other thing is that outside, when we're adding, shifts up. So it's going to go up. But we also said that when we're multiplying inside, which is this one right here, if b is greater than 1, right, a whole number. I just realized that I had them backwards. So it's whenever b is greater than 1, then that's when you'll get a compression So from a regular one, it's going to be skinnier. And then when it's less, meaning a fraction, then it's going to be a stretch. Let me explain them. When we have a f of x, meaning that you're multiplying the function by a number outside, and that number, which is the coefficient, is greater than 1, meaning a whole number like a 2, an 8. If it's greater than 1, it's going to be a vertical stretch, meaning it's going to go like this. It's going to grow tall. Each point will go up. If it's a fraction, then that means that a is less than 1. And so therefore, it is a vertical compression. So instead of having, for example, in here 4, you have 1/2 of that, this will go down. It's compressed, okay? But what we're going to be looking at is this one right here. When we're multiplying inside, it's being represented by b. And when b is greater than 1, then it's going to be a horizontal compression. That means that each point is going to be compressed closer to y. So this point will go like this point will go like this point will go like that, and so on, okay? But if b is a fraction, meaning that b is less than 1, like 1/3 or 1/8, inside of the parentheses or the absolute value or of the square root, then it's going to be a horizontal stretch. Each point will go away from y, okay? So again, you can see that whenever it's outside, the effect is on y because the points grow up or down, like it shrinks. And when it's inside, the effect is on x because your points go change on x. It goes from here to being in here, okay? Okay, so again, with transformations related to compressions and stretches, we're not going to be exact. The first thing that we want to do is this compression, right? Because it's b is greater than 1, it's a 3, so it's going to be a horizontal compression. And so you would do something like this where your graph is skinnier, it's closer to the y. And then from there, you would just move, if that's what they're asking you, you would just move this point 3 spaces to the right. So 1, 2, 3, and 2 spaces up. 1, 2, right there. Okay, after you find or do this transformation of making it compressed, horizontal compressed. And from there, you already did the 2 translations and this by making it skinny. So you would just create something like that. Now, that's a more or less graph, a new graph. But what if you wanted to do or be more, what you can do is look at the values of x, and you can do the table mentally, kind of. Let's say that x is 0. 3 times 0 is 0, minus 9 is -9. Square that is -9 times -9 is positive 81, plus 2 will be 83. So 0, 83 will be way up there because it doesn't fit in our graph. How about for the value of x equals 1? 3 times 1 is 3. 3 minus 9 is -6. -6 times -6 is positive 36, plus 2 is 38. We still don't have enough. Okay, the next one is a 2. 3 times 2 is 6. 6 minus 9 is -3. -3 times -3 is 9, plus 2 is 11. So for 2, you will have 11, 2, 4, 6, 8, 8, 10, 11. It's right there. Now let's do 3. 3 times 3 is 9, minus 9 is 0, 0 squared is 0, plus 2 is 2. That's that point right there. The next one will be 4. 3 times 4 is 12. 12 minus 9 is 3. 3 squared is 9, plus 2 is 11. So for 4, you will get 11 right there. So that's how skinny and compressed our graph gets, okay? That we cannot graph more than 2 points if we were to do a table. And so that's why for compressions and stretches, we kind of do just kind of like, oh, just make it skinny and then move it when you have to. Move the vertex and then you just guide yourself with the rest. Notice how they're very close, but not quite. Now, I would take a minute to show you Desmos. Please try to do it on your own so that you can learn it. Otherwise, if the calculator does it for you, you will never learn. And so this is Desmos.com. It's a free app online. And what I do, I just press Y equals. But I want you to see it as well. Let me see if it shows in there. Yeah. Open the parentheses. Put 3x. And you know what? I'm going to close it so that you can see what happens when you square it. It just made it skinny. Okay, so let me go back in here. Erase the 3. If you have x squared, you just get the mother graph that I already had over there. I put times 3. That make it compressed. Vertically compressed because it's inside of the parentheses. Then this arrow allows me to move it. So now I'm going to subtract the 9 minus 9. Look at what happened. It moved 3 spaces to the right. That's my negative 9 divided by 3 is the 3 spaces to the right. And then finally, plus, whoops, but not inside, plus the 2 that it's outside. It makes it go up, the 2 spaces. Okay, so let me close in here so that you can see the difference. Again, the 3 made it compressed, closer to y for each point. And then negative 9 divided by 3 made it move to the right, 3 spaces, and then 2 spaces up. Sorry that it looks, it's because we can move this to be 1 per square. Okay, and you just move it from the axis. So you can do the same thing if you want to see. Okay, and play with it. See in here now a 1 is represented with 2 tall squares. So yeah, you can play with it and see. Again, try to use it just to compare. Don't use it to make your homework, just to compare it and see how it looks. So having a half outside, that means that A is less than 1. And it's going to be a vertical compression. So each point is going to go shorter. And in here, because it's 1/2, it's a little easier to really see that. And then you just move the graph 5 spaces down. So this, because it's negative, you're subtracting outside, is going to shift down. But then the fraction is outside of the parentheses. How would it look if it was inside? Y is equals to, open your parentheses, 1/2 inside, x, the square will be outside, and then minus 5. Maybe I can show you in Desmos the difference between the two. What I recommend doing is this half first of each point and then going down 5 spaces from there. So 0, 0. Well, half of 0 is still 0. Minus 5 is 1, 2, 3, 4, 5. It's right there. In here we get half of 1 is 0.5. Then you move 1 space, 2 spaces. Notice how I'm going in the halves because I ended up with half. So a whole square it would end up in another half. So half of that is here, and count 1, 2, 3, 4, 5 is right there. For this one, half of 4 is 2, count 5, 1, 2, 3, 4, 5 is right there. For number 9, half of 9 is 4.5, so right there, and count 1, 2, 3, 4, 5. You count in the middle because you have 4.5, okay, and 5 spaces down, you end up in there. So notice how already it went down, each point went down 5 spaces, but at the same time, my graph got compressed. Look at how chaparrita this is. Okay, so the same thing is going to be for this one. Half of that is here. So 1, 2, 3, 4, 5. But you can also do the mirror of this one. This one is right here, so the mirror is going to be there. This is 3 spaces and half of that, so 3 spaces and half in here. So each point got closer together to your x or to your vertex. Okay, see, this is supposed to be this one from here to here. Look at how far they are, but from here to here they're closer because it got compressed. Okay, it got compressed and then it moved down 5 spaces at the same time. So to finish our lesson, that's our mother graph. And so you have y equals 1/2 is 1 divided by 2. Move to the right with these arrows, and then you put x squared minus 5. Minus. So just the x squared, look at what that did. So the original is the lighter blue, and then the darker blue is, it's compressed. Okay, each point got closer to x. Minus 5 is just going to go down 5 spaces. Okay, let me show you. I have to grab it from the x-axis. So notice how it went wider or compressed when I first multiplied by 1/2, and then it moved 5 spaces. There you go. 2, -3. It's right there. Now let me put this one, the one that is inside of the parentheses, which is a horizontal stretch. Okay, it's supposed to go like this. So each point is going to go far away from here and then also move 5 spaces down. But let me show you how it looks in Desmos. Y equals, open a parenthesis, 1 divided by 2, put x, or move to the right, and then move to the right or open the parentheses. Close the parentheses, and then you square that. This is the green one now. This is the mother graph, and that went away. So it gets wider. It stretches horizontally. The points go away from y. Okay, meaning that it changes, the value for x changes. If it was a 1, then it's going to change to something else. Let's now subtract the 5. So -5. It still went down 5 spaces because it's outside. Okay, so it went down 5 spaces. But notice how it affects even more, because the 1/2 makes it stretch away from y farther than each point compressed in half. Okay, why did I do these two comparisons? Because I want you to understand that when you have a fraction, for different reasons, in here it gets closer to x, but at the same time makes the graph itself look a little chaparrita. And when it's chaparrita, it looks gordita, right? It's wider. In here, it's because it stretches. Each point stretches away from y, meaning it changes on x, the value on x changes. But again, when it's a fraction, you end up with a wider graph for different reasons. But because the points shorten, or because they stretch on x. So shorter on y, smaller numbers on y, or longer numbers on x make the graph look shorter and wider. When you have a whole number, each point stretches or makes it tall. In here, it makes it skinnier or closer, but again, the effect is very similar. In here, you get a tall, skinny graph. In here, you also get a skinny and tall graph, for that matter. Okay, for different reasons, you end up with the same when you're multiplying by a whole number, or you get the same when you're multiplying by a fraction. Share. Also, don't forget to click the bell so that you can get notifications of new videos. If you would like to visit us for fun videos related to math and science, you can find us on TikTok at MathMaria7. We will really appreciate your support by giving us a thumbs up, subscribing around here. This is the link to the entire unit, transformations, and we have it algebraically. Here you will find the next lesson. Now you're able to do 8.5 and have fun.